Hello guys, in this video let's see about basics of Mosfet in detail. So before going into the basics of Mosfet, let's see about BJT and its advantages as well as disadvantages. So there is a BJT is a bipolar junction transistor with three terminals. Base is the control input and collector and emitter are other two terminals which will be in on or off condition depending on the base input. So how this works. So when base current is more than a threshold value, collector and emitter will be shorted and it will be acting as a conductor. So, so the transistor will be at on condition. So in the same case when the base current is less than the threshold current, the collector and emitter will be of open circuit and it won't conduct current between these two terminals, which will result in off condition of the transistor. So this is the basic of BJT, and the advantages are the noise is very less. Basically the output given by the transistor is a very less noise. Less noise meaning the probability of noise being there in the output signal is less, and the power consumption is also less. So these are the advantages of BJT. So what created problem in BJT which resulted in replacing BJTs by MOSFETs? So there is one disadvantage in BJT. What happened was when the number of transistors kept increasing in a chip, there comes the problem of power. And in BJT there is a minor problem where even when the transistor is at idle condition, there will be some minor base collector and base emitter current which will result in power dissipation. So when the number of transistors increase in a chip, this power dissipation is a major problem which results in heating and other related stuffs. So this is the disadvantage of BJT. So how does MOSFET overcome the disadvantage of BJT? First let's see about MOSFET. So MOSFET is divided as N-channel MOSFET and P-channel MOSFET. These are the two types of MOSFETs available. First I'll tell you the design of MOSFET. So in case of N-channel MOSFET, there will be P substrate, and in P substrate there will be two N wells. So these two N wells are source. One is source terminal and the other one is drain terminal, and this is the gate terminal in between. So the lower layer is an insulator. It is made up of silicon dioxide. It is also called as glass. So the upper layer is a conductor. It is made up of polysilicon, and this is the gate terminal. So this is a simple diagram of N-channel MOSFET. The diagram of P-channel MOSFET is here. It is the exact opposite of N-channel MOSFET. In place of P, N will be there in P-channel MOSFET. So this is a basic diagram. So before going into the working of N and P MOSFET, I will tell you the name reason behind N and P MOSFET. So full form of MOSFET is metal oxide semiconductor field effect transistor. So metal oxide semiconductor. First I'll tell you about metal oxide semiconductors. Then I'll come to the field effect transistor part. So as I told you, the conducting part, the top layer, is made of polysilicon nowadays. I mean, initially when MOSFETs were introduced, this polysilicon layer was made of a metal, and there was no more polysilicon at that time. So they later replaced it with polysilicon. Earlier, metal was used for this gate terminal. So this word metal came into picture. Then oxide semiconductor means This insulator is made of silicon dioxide. So obviously this oxide is because of the silicon dioxide layer in between gate terminal and the P substrate. Field effect transistor. So this MOSFET works on electric field. This entire operation of MOSFET is based on electric field created. So I'll explain that in the next slide. So this is metal, this is oxide, semiconductor, and field effect transistor is because electric the entire MOSFET concept is based on electric field created. So this is the reason behind the naming of MOSFET. And one more thing I forgot to tell, there is one more terminal in MOSFET. It's called body or bulb. This entire P substrate is called body or bulb. Here this entire N substrate is called body or bulb. So these are the things which we have to know about MOSFET. Next we'll go to the working of MOSFET. So at first we'll see MOSFET. So as we all know, gate is the control part of the transistor. So depending on the gate control, the transistor will act as on condition or off condition. So first for NMOS, we'll assume the gate voltage is low. So possibilities are low and high. So when the gate voltage is low, what will happen? Here electrons will be there, and at this part holes will be there. So when holes are there, there is no relation between source and drain. So source and drain cannot conduct current because there is no connection between them since holes are there. So before going into this, I want to say one more thing. In case of N MOSFET, this body terminal, it is grounded just to make sure that the source and drain junctions are reverse biased. So first thing is there are four terminals in N MOSFET, and the body terminal is grounded for reverse bias condition to be ensured in N MOSFET. I mean ensured in source and drain of N MOSFET. So let's start again. So when the gate voltage is low, here in this part electrons will be accumulated because this is an insulator, this is a conductor, and again here there is a conductor. So here electrons will be there, which will result in holes in this part. I mean this electrons will create an electric field on the other side, which will result in accumulation of holes here. Just no impact because already there are holes in the entire thing, and there is no way of electron transfer from source to drain or drain to source. So this is the off condition of N MOSFET. I mean when gate voltage is 0, there is no conduction between source and drain terminals. So this is the off condition. So, so if we increase the gate voltage to high, what will happen? The upper part, the upper layer near the junction, holes will be settled because positive charge is applied, high voltage is applied. So under this insulator, because of this holes here, there will be electric field created in this side, which will result in accumulation of electrons here because there are holes on the other side. So N particles will be accumulated here below this insulator resulting in formation of a channel between source and drain, which in turn will result in conduction between source and drain terminals. So this is how MOSFET acts as a switch. So when gate voltage is 0, there is no conduction between source and drain because because there is a reverse bias junction, reverse bias source and drain junctions everywhere. When voltage is released, because of the electric field, electrons are accumulated here, resulting in the formation of channel between source and drain, which in turn results in conduction between source and drain terminals. So this is the working of n MOSFET. So if we go for p MOSFET working, it will be the exact opposite of what we saw in n MOSFET. So in n MOSFET, the body was connected to ground. In p MOSFET, body should be connected to high voltage, again to ensure source and drain reverse bias conditions. So similarly, we'll check here. Consider the gate voltage is low. What will happen here? There will be electrons accumulated, will result in electric field on the other side, which in turn will result in accumulation of holes here below this insulator. Holes are accumulated here. There is a connection between source and drain terminals, because source and drain terminals are made of holes. So the source and drain, there will be conduction, resulting in on condition of the transistor. So this on condition will happen when gate voltage is low. So consider the gate voltage is high now. What will happen here? There will be holes settled in this junction, resulting in the electric field here, and the electrons will try to come here. Just no impact, because source and drain can anyways not be conducting, since only electrons will be settling here, resulting in no impact. So this is the off condition of P MOSFET. So when gate voltage is 1, there is no conduction between source and drain, resulting in off condition of P MOSFET. So this is how MOSFETs in general act as a switch. So one more thing, I already will be base in collector current and base and emitter current in BJTs, which will result in power dissipation. And it is a major disadvantage when millions of transistors are there together in a chip. So how does MOSFET avoid it? As I already told, here there is no conduction between gate and source or gate and drain, because there is an insulator between this part of the transistor and gate, which will not allow electrons to pass through gate, resulting in zero current between gate and source or gate and drain junctions, which will result in approximately zero power dissipation when the transistor is at idle condition. So this is the advantage of MOSFET. And one more advantage is faster switching. Since MOSFET is voltage control, the switching is much faster compared to BJT, because BJT has two junctions which must be reverse biased or forward biased depending on the voltage and depending on the voltage. So MOSFET switching is much faster compared to BJT, because BJT is a current controlled transistor and MOSFET is a voltage controlled transistor. So that is all I wanted to say in this video. I'll continue in the next video. Thank you.